Good morning, dear students. Welcome to Target JE video, class 12 physics. Our first lesson is electric charges and fields. In this video, we are going to discuss about the various concepts which are very important for the JE examination. Already asked concepts and also going to ask the concepts and all we discuss here. And after the concept discussion followed by problems, our intention is you must get a good grip over the concept and do the problems. So you have to develop the problem solving skills. So let us go back to our chapter. Today our concept to be discussed is electric charge. First we discuss about the basics of electric charge. Charge, we know that, is a basic property of matter. A matter is having atoms. In atoms, we are having nucleus, and around the nucleus, see, this is an atom. Positive nucleus will be there at the center, and electron is revolving around the nucleus. So positive and negative charges are there innately in all types of material. So the property of basic property of matter, the intrinsic property of a matter is having a charge. Here we take a basic charge. Basic charge is the charge on electron. So we take a charge on electron as a basic charge. Why? Because it is easy to have a electron to add to a body and remove from the body. It is very easy. And next thing, the electron is a very stable particle. And the third advantage is whatever the speed a charged body or electron moves, the quantity of charge, the magnitude of charge never changes. Whereas, according to theory of relativity, mass, length, time will change if body moves with some speed. So, here it won't happen. Whatever the speed the electron moves, its quantity of charge never changes. So we have taken a electron charge as a basic property of a basic charge in nature. Actually, so many subatomic particles are there having less than charge on electron, but these particles are not stable. Electron is only a stable particle. That's why we have taken the electron charge as a basic charge. What is the electron charge value? Electron charge value is 1.6 into 10 to the power of minus 19 coulombs of negative charge. Electron is having, any charged body is having two natures, the positive type and negative type. This is called the polarity nature of the electron. It is having positive and negative nature. So this property of charge is called polarity, positive polarity and negative polarity. And also charge is a scalar. Scalar means it is having only number, a magnitude. Next property of charge is charge always conserves. Charge always conserve. That means charge cannot be created nor be destroyed, but we can have a charge on body by adding and removing electrons. Generally, we take the symbol for charge is small q. So small q charge is equal to IT. It is the formula. I is the current and T is the time. And dimensional formula of charge is AT at. IT formula, AT at is dimensional formula. So these are the things you have to remember about the basics of a charge. You also know that like charges repel each other and unlike charges attract each. Next point is electrification. Electrification means having a charge. Producing, I am not using. Why? Because we cannot newly produce a charge or destroy a charge. We can have a charge on a body. How can we have a charge? That is called electrification. So, first method to have charge is friction. By rubbing two bodies, we can create charges on bodies. That method of having charges is called frictional method. The electricity which comes out due to friction is called frictional electricity. So, how it happens? See, we take a glass rod. Actually, to have a charge so that we can check it, the charge, one body should be a insulator. So we are rubbing two bodies, one body should be an insulator. See, we know there are two types of materials, conductors, good conductors and bad conductors. Bad conductors are called insulators. What is the difference between them? In insulators, the electron cannot move freely inside a conductor. There is a restriction for electron. That's why it could not move freely. Whereas in conductors, electron freely move inside a conductor. So one body should be an insulator so that we can have a charge and we can see it. Even it is a conductor, if you rub it, charges will produce, but these charges will move it to our body. Why? Because human body is a good conductor of electric charges. That's why one should be a non-conducting body. So I have taken a glass rod. And second material I have taken is woolen cloth. Woolen cloth or silk cloth or fur. So I have taken two bodies and I rubbed it. I will get one type of charges in one body and another type of charges on another body. Why we are having? Why? Because if we rub, we are supplying thermal energy to the valence electrons in a material. When they take this thermal energy, these valence electrons get free and they can travel, they can be transferred from the one body to the other body. See, which body gives electrons, which body takes the electrons. That is the point. See, glass rod is an insulator and its electron affinity is less. So, if electron affinity is less, it gives away electrons. The body which is having more electron affinity, it will take the electron. So, as glass rod is having less electron affinity, it transfers electron to the woolen cloth when we rub both of them. So when electron goes, here we say positive charge is developed. Positive charge developed on the surface of glass. All electrons are transferred. Here 1, 2, 3, 4, 5, 6. Positive means the electron is removed, transfer, taken off. That's why here the deficiency of electrons are there. So less is the electron, that means it became a positively charged. Here on this body also electrons are there, but the electron given by the glass rod also extra electrons comes onto the surface of woolen cloth or silk cloth or fur. So X of electrons are there on the surface of silk cloth. That's why this body we call as a negatively charged body. This is negatively charged body. This is positively charged body. So charging means adding. See, I will write that point. Charging. Charging means adding or removing electron, adding or removing electron. So this part here, this electron easily can be added, easily can be removed. That's why we have taken charge on electron as a basic charge. So adding of electrons, see here we have added the electron. Excess electrons are there. Whenever we add, the body becomes negatively charged. Whenever we remove electrons, that body becomes positively charged body. So positively charged body, deficiency of electrons. Negatively charged body, excess of electrons. So a body which is having less electron affinity loses the electron. The body which is having more electron affinity, it will take the electron. One body becomes positive, another body becomes negative. Because of friction, because of rubbing this woolen cloth and glass rod, we have seen the electrons on their surfaces. That's why this method is called frictional electrification, method of electrification by friction. The charges we are seeing are frictional electricity. So this is what about the frictional electricity, frictional method of electrification. See, before we rub the bodies, gas rod are not having any charge and woolen cloth is also not having any charge. After we rub, this body became a positively charged and another body becomes a negatively charged. That's why after frictional electrification, these two bodies attract each other. Next method of electrification is conduction. Conduction means two bodies will be there. One body is fully charged, another body doesn't have any charge. If the fully charged body is touched with, made a contact with uncharged body, the charges will flow from charged body to uncharged body. This method of transferring electrons, getting the electric charges on the surface of bodies is called the conduction. See here, let us take a body A. This is a body A. It is a positively charged body. So, 6 positive charges are there. And this body B is not having charges. So, it is not having charges. Now, what we did, we made a contact. This body, both bodies comes into contact. This conduction never takes place without contact. When we contacted both of them, these charges from positively charged body, the charges will flow to uncharged body. So this is called conduction. How many charges will flow? See, till the potential on both of them bodies becomes equal. So these charges, they will share each other. So to understand properly, we just take some charges. Let us take, this is a before conduction situation. After conduction. So before conduction, let us take, it is having plus Q1 charge and it is also having plus Q2 charge. So after conduction, what happens? This is before conduction. After conduction, how to calculate? Let us calculate. What is the net charge? Net charge means total charge on both the bodies. This is having Q1, this is having Q2. So Q1 plus Q2 is the net charge. This net charge, these two bodies has to share in conduction. How they share? Each body charge How much? Two bodies are there. Total charge is Q1 plus Q2. How they share the charges? Q1 plus, sorry, Q1 plus Q2 by, this is the charge they will share. So average charge. So after this conduction, this body have the charge q1 plus q2 by 2, and body B also gets the charge q1 plus q2 by 2. This is also plus type of charge, this is also plus type of charge. Like this, conduction takes place. I will give further some examples so that you will have that idea into your mind. So let us take this body A is having plus 8 coulombs of charge. Coulomb is a SI unit of charge. 8 coulombs of charge. Actually, coulomb is a very big unit. In our practical purposes, we won't use coulomb, we use nano coulomb. So I will write here nano coulomb. Nano means 10 to the power of minus 9 coulomb, or micro coulomb 10 to the power of minus 6 coulomb, or milli coulomb 10 to the power of minus 3 coulomb. Like this, fractional values of coulombs only we use for the practical purposes. Anyhow, to understand here, we have taken a coulomb. 8 positive coulombs of charge it is having. So, this body B is not having any charge, not having any charge. Now we made a contact. Conduction takes place. So whenever we make two bodies come into contact, the charge flow from charged body to uncharged body. So what is the net charge here? 8 plus 0, 8. Two bodies are there. 8 by 2 is 4. So after conduction, it is having plus 4 charge, and this body B is also having plus 4 coulombs of charge. This is conduction. See, same formula we have used, 8 plus 0. Suppose for example, I will give another example. Before, the body A is having plus 4 coulombs of charge, and body B is having plus 2 coulombs of charge. Now we made a contact. So whenever we made a contact, charges flow from wherever the more charges are there, from that more charges body to less charged body, the electrons will flow. So charges, when they are flowing, what will be the final charge here on A? Final charge on A. Net charge first we have to calculate. What is the net charge? 4 plus 2, 6 coulombs of charge. That 6 coulombs of the charge, both A and B have to share. That means 6 by 2, 3 coulombs. So it is having 3 coulombs of charge, and this body is also having plus 3 coulombs of charge. So this is due to conduction, the charges became like that. One thing you remember in all examples, before contact, charges are different. But after contact, charge magnitude on both of them, on body B also 3 coulombs of charge is there, and magnitude of charge on the body A is also 3. And type of charge, this is plus on B, here also type of charge is plus only. On both the bodies, quantity of charge, magnitude of charge, and type of charge is same. That's why like charges repel each other. After conduction, both bodies repel each other. One more example we'll see. Plus 8 coulombs of charge is there. On body B, minus 4 coulombs of charge is there. Then, if conduction takes place, if we made the bodies, both the bodies to contact, What happens finally, how much charge they will acquire? So we have to add. See, while you are adding, the negative sign also you have to take. What is the total? Plus 8 minus 4. This is the total. So net charge is plus 4 coulombs. Two bodies has to share it. So plus 4 by 2 is equal to 2 charges. So plus 2 coulombs charge will be on A, and on B plus 2 coulombs will be there. So net charge they are sharing. So after conduction, always the magnitude and type of charges on both the bodies is same. Final example we'll take. This is a minus 8 coulomb. Here also minus 4. Then what happens? The net charge is minus 8 minus 4, that is minus 12 coulomb. So minus 2 coulomb they have to share each other. So if they share each other, what happens? Minus 12 by 2, 6, minus 6, minus 6 coulomb, minus 6 coulomb. See, the magnitude of charges are equal on both bodies and type of charge also equal. When conduction takes place, both bodies repel each other. Third method of electrification is induction. In induction, there shall be no contact at all. See, we are having a body which is positively charged. How many positive charges are there? 1, 2, 3, 4, 5. So I may say plus 5 coulombs of charge. And I brought near to an uncharged body. This body doesn't have any charges on it. It is uncharged body. I made no contact. I just brought near this charged body to an uncharged body. Then what happens? On uncharged body, negative charges will be induced. Here 5 is there. Here 5 electrons will be, 5 negative charges will be induced. So this here charge 5 negative charges. So if 6 positive charges are there, minus 6 negative charges will be developed because of induction. No contact will be there, just one body we brought near. This is a charged body, we brought near uncharged body. On uncharged body also charges will be induced, but opposite types of charges will be induced. If it is a positive, here negative. If it is a negative, here it is positive. That is called induction. Like this we can have charges on the surface of body. So after induction, what happens? See, here also 5 coulomb magnitude, here also 5 coulomb magnitude, but type of charges are opposite. That's why after induction, always those two bodies which are indulged in induction attract each other. Why? Because the opposite charges will be there. The type of charges are opposite, but magnitudes are same. See, I have taken a body. This is a charged body. 1, 2, 3, 4, 5 charges are there. So total 10 charges are there on body A. So this is positively charged body. I brought near this positively charged body to an uncharged body. There are no charges on the surface of B. When I brought near this uncharged body, opposite charges will develop on the surface of uncharged body. See here how it takes place. Positive is there, negative. 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 But on the other side of the conductor B, positive charges will be. Why? Because if we bring a positive charge near an uncharged body, the center of mass of the negative charge and positive charge separates in a atom. In atom, positive charge also there, negative charge also there. So negative charges get attracted with the positive charge, so they come near and positive charge will be repelled by this positive charge. It moves away. This is called the polarization of charges. So this polarization of charges takes place in induction. If I remove this charged body, immediately these charges merge each other, they recombine, and there shall be no charge on the body until unless this charged body is near to uncharged body. On the surface of uncharged body, the opposite for charges we can see, whichever the surface near to the positive body, and other side positive charges will be there because they will be separated, and when the positive charge is taken off, both will remerge. That's why no charge we can find after the induction. Next point we are going to discuss is detection of charge. The primary detector of charge is gold leaf electroscope. How the gold leaf electroscope functions, let us see. Gold leaf electroscope is having one brass circular disc. So it may be like this, brass circular disc, and it is connected to a copper rod. At the end of the copper rod, two gold leaves will be there. Very, very thin gold leaves will be there. Gold foil will be there. So this is made up of brass disc. This is copper rod. And these are gold leaves. So this whole arrangement is fixed inside a vacuum chamber. So this is a vacuum chamber. Why we are placing this arrangement in a vacuum chamber? Because if any air is there here, any gas is there, because of the charges on gold leaf, it get ionized. So the charge on gold leaves will be leaked out. So we cannot calculate the quantity of charge perfectly. That's why always this arrangement we put in a vacuum chamber. How it works, let us see. If due to conduction, I have taken a positive charge body and made a contact. Because of contact, what happens? All the positive charges will be transferred to the brass disc. Brass disc, it will supply the positive charge to the copper rod. Copper rod transfers the positive charges to the gold leaves. Because of the positive charge, these gold leaves repel each other. Why? Because positive charges will be spread on the surface of gold leaves. So some angular displacement taken place. See, by calculating the angular displacement between the two gold leaves, we can calculate the magnitude of charge on the leaves of a gold. So like this, it can be detected. The charge can be detected and charge can be calculated by this. See, if I remove this positively charged body, yes, detection is over. So I detected a charge on that rod and I calculated the quantity of charge also, but I removed. After using this gold leaf electroscope, still the both leaves will be separated only. Why? Because this positive charge never goes anywhere. So to neutralize, to take off the charge, I have to touch this gold leaf electroscope brass disc with a negatively charged body. Then what happens? This negative and positive rejoin each other, and this go all the charge will be neutralized. Once again both gold leaves will come. Like this we can discharge, we can take off the charge from gold leaf electroscope. Just I brought near a negatively charged body. I made no contact near the brass rod. Immediately what happens? Opposite charges will develop on the disk. If positive charges are there, because of induction, here positive are there, so they become negative, and same negative will be flowing to the gold leaf, and immediately both will be deflected. Some angular deflection comes. By calculating the angular deflection, we can calculate the magnitude of charges also. If I take off this body, this negative positive charges in that bodies in this brass disc and gold leaf and the copper rod, automatically the charges will disappear when we use the gold leaf electroscope. Next point is properties of charges. So we know that charges are scalars, like charges repel each other, unlike charge attract each other. Together with them, these three properties are very important. First one is quantization of charge. Always charge quantizes. That means, see, we already know that charging means adding electron or removing electron. So in steps of electron charge only, the charge on a body increases and can be decreases. So if any physical quantity is increasing or decreasing with discrete values, then we call it quantization. So here charge always quantized. That means, see, suppose for example, one body is there. To this body I want to give charge. So I have to charge a body means I have to supply one electron. So how much charge is there on this body? One electron charge is there. One electron charge means 1.1 into 1.6 into 10 to the power of minus 19 coulombs of charge. If I want to further charge that body, I have to give one more electron to that body. So now the charge of the body is 2 into electron charge, that is 2 into 1.6 into 10 to the power of minus 19 coulomb. If I want to further increase the charge on the body, then I have to supply another electron to it. Then what happens? The charge value becomes 2 into electron charge, that is 2 into 1.6 into 10 to the power of minus 19 coulombs. As we are giving electrons, the charge value is negative. So here you see, if I give one charge, one electron, then the value of the charge on the surface of body is 1.6 into 10 to the power of minus 19 coulomb. If I supply 2 electrons of charge to a body, then this is 3.2 into 10 to the power of minus 19 coulomb. So we can either charge a body to 1.6 into 10 to the power of minus 19 coulomb or 3.2 into 10 to the power of minus 19 coulomb. In between charges we cannot have. So in steps the charging increases, or in steps the charge can be decreased. So this thing we can simply express the quantization of charge like total charge given to a body is equal to number of electrons into charge on electron. Like that, we give a formula. See this charge of electron. E means charge on electron. So value only we have to take. Same number of electrons if we remove, then body becomes positive. Same number of electrons we have supplied, so the body becomes negative. So Q is equal to total charge on a body is equal to number of electrons and charge of electron. N belongs to the integer. Suppose for example, 1 coulomb charge if I want to give to a body, so body I want to give total charge 1 coulomb. Electron charge I know, that is 1.6 into 10 to the power of minus 19 coulombs. If I want to charge a body to 1 coulomb, how many electrons I have to give? n is equal to question mark. Then n is equal to, see from this formula, n is equal to q by E. Q is 1 coulomb. This is 1.6 into 10 to the power of minus 19 coulombs. So this is 6.28 into 10 to the power of 18 electrons. So if I supply 6.28 into 10 to the power of 18 electrons to a body, the body gets 1 coulomb of negative charge. If I remove 6.28 into 10 to the power of 18 electrons from a body, then the body gets plus 1 coulomb of positive charge. Second property of charge is charge always invariant. Second point, charge always invariant. So already we came across this property of electron. So whatever the speed of that electron, the charge on it never changes. Whatever be the speed of a charged body, the magnitude of charge on its surface never changes. So that is called charge is invariant. The third point is, we already know that charge is a scalar. Scalar means only magnitude they are having, they are numbers. So easily we can add it. So we need not worry about the direction. So that is called additive. So charge is additive. That means if in a small region, in this small region, we are having plus 1 coulomb charge and minus 2 coulomb charge and minus 3 coulomb charge and plus 6 coulomb charge and plus 4 coulomb charge. Like this, several charges are there in a area. Then what is the net charge? So net charge is equal to, just simply you add. How we add? See, plus 1 coulomb, minus 2 coulomb, minus 3 coulomb. So the sign we should not change. Plus means always not plus. If it is a minus, we have to write minus charge. If it is a plus charge, we have to write plus charge. So after that, plus 6 coulomb and plus 4 coulomb. Like that, simply we can add. So how much it is? See, 3 and 2, 5. So 4 plus 1, 5. So this is please 6 coulomb. So by simply adding charges in an area, in a region, we can calculate the net charge in that area. So this is charge additive. So these are the properties of electric charges. Next our point is distribution of charge. If we give supply charge to a body, where it resides? Materials, three types. Insulator. Insulator means non-metals. Next, semiconductors. Next, conductors. These are metals. If we supply charges, how charge distribute in that kind of materials we discuss. Insulators first I'll take. I will write non-metals. Non-metals means insulators. Non-conducting materials. I have taken a non-conducting material in form of a rod. If I supply charge to a rod, all the charge resides along the length of a rod. If I give charge to a non-conducting material, all charge resides on the length of a rod. So if we want to calculate the net charge there, or we want to calculate what is the charge per unit length, then the charge per unit length is also called as linear charge density. So linear charge density symbol is lambda. Charge per length. Charge is distributed along the length. SI unit is coulomb per meter. If I take this is the one dimensional body. If I take a lamina, if I supply charges all over the area of this lamina, insulated material, non-conducting material, all over the area, the positive charges reside. If we want to calculate the charges there, areal charge density. Areal charge density we calculate. Areal charge density symbol is sigma, charge per area, coulomb per meter square. This we can calculate. If I take a three-dimensional body like a non-conducting sphere, non-conducting sphere. Sphere is a three-dimensional body. If I give charge, so here charges reside inside and outside all over the body. So like that, charges will distribute all the volume of a body. Volume charge density. Symbol for volume charge density is rho is equal to charge per volume, coulomb per meter cube. Like this, we will calculate. If we want to say the electric field inside the non-conducting sphere, electric field is not is equal to 0. Why? Because wherever charges are there, there exists the electric field. Outside also electrons are there, so outside the this non-conducting sphere also electric field never becomes 0. So some finite value will be there for the electric field. In the case of semiconductors, intrinsic charges will be there. By birth, the semiconductor material, they are having charges in them, so we cannot charge from outside. Already charges are there, free charges are there in them. So n type, p type semiconductors are there. N means negative charges will be there by intrinsic property of that one, and p type means positive charges will be there. So we won't discuss about semiconductor. Why? Already they are having charges. Non-conductors, they don't have charge, we are supplied. So where the charges distribute, we have discussed. Now let us discuss about conductors. Conductors means naturally metals. Metals, the electrons are having freedom to move everywhere inside a conductor. So for conductors, see, I have taken a rod. This is a conducting rod. I have supplied a charge. This charge resides always along the length of a rod. So here also we can calculate linear charge density, charge per length. And if I take a lamina, a metal sheet, conducting sheet, right? In a lamina or a sheet, thickness is very less, area is very high value. Area is more. In metal sheet, the thickness is less, area is more. So if I give charge to this, all the charge resides on the surface of a conducting sheet. So we can calculate charge per area, areal charge density. If I take a sphere, what sphere it is? Conducting sphere. If I take conducting sphere and if I give charges to a conducting sphere, here electrons free to move. All positive charges are there, like charges repel each other, and all the charges repel each other and goes to the surface of a conductor. So if I give a charge to a sphere, inside no charge will be there. Why? Because of repulsion, they will repel and they will reside on the surface of a conducting sphere. So inside the volume there is no charges. That's why for this case, so here for sphere also we have to calculate the areal charge density, charge per area. It is a sphere. So if a sphere radius is r, then the surface area of the sphere is charge per 4 pi r square. Like this, unit coulomb per meter square. Inside there is no charge. That means what? Inside electric field is equal to 0. Outside electric field is not equal to 0. Why? Because inside there were no charges. That's why the electric field also 0. So like this, charges will distribute in the case of conductors. So all rod uh, and lamina or metal sheet, a sphere, these are all regular bodies. If I give a charge to a irregular conductor, what happens we see? See, I have taken a irregular shaped conductor. So irregular conductor. And I have supplied charges. If I supply a charge, see here more charges will accumulate. Here less charges will be there. Like this, charges will distribute on a irregular conductor. So how to study this one? See, this is a curve. Each curve, any curve is a part of a circle. So this is R1. This curve also considered as a part of a circle. This radius is R2. So this radius is called radius of curvature. So what is the nature of charges? If I give charge to irregular conductor, wherever the radius of curvature is less, there more charges will accumulate. Wherever the radius of curvature is greater value, then less charges will be residing there. So this you have to remember. See, in a conductor, charges always resides on the surface of a conductor. Inside, no charges. That's why we can say irregular conductor surface charge density is inversely proportional to R. R is what? Radius of curvature. So it is so this is a surface charge density. If radius is less, more charges. Radius is more, less charges will. So this property of a conductor we use to safeguard skyscrapers and important buildings from lightning. See, suppose for example, this is a big ground. One skyscraper is there here. So in rainy season, a lightning came. Lightning is having large amount of charge. When charge sees from the above from the clouds, so wherever the radius of curvature is less, the charge goes there. Why? Because if radius of less is radius is there, more charge will go there. So if this playground is there, radius of curvature is more large. But here the radius of curvature of the building is less. So the lightning falls on the building and it is electrified and burned out. So to safeguard from this, we place a copper rod having small copper umbrella. See, if we see the copper umbrella, it is having less radius of curvature than the surface of ground and surface of a skyscraper. Then what happened? This lightning will fall on it. So large amount of charge will be falling on that copper umbrella, and that charge we say one with one wire we connect that one to a ground. So all the excess charge will flow to the ground. Why? Because earth is a good conductor of electricity. That's why all the charges will move into the ground. You can see in your town also, if you see on the top of a police station, we'll have a very big mast, and a small umbrella type of mast is tied there on the top of a police station. Why? Because it's also a important government building. So to safeguard buildings and skyscrapers, we use this property of charge. What is that property of charge? The surface charge density is more when radius of curvature is less. So charges always accumulate wherever the radius of curvature is less. So finally, suppose one body is there. So this is a cavity, one sphere. Inside the sphere, some cavity is there. In that cavity, one side I placed a positive charge, at one side inside the cavity I placed negative charge. This is a cavity like this, a cavity. Inside the cavity, at one corner I placed a positive charge, one corner I placed a negative charge. Then net charge is net charge in the cavity. Net charge in the cavity we have to add. This is property of additive property of charge. Plus charge minus charge is equal to 0. But they ask the surface charge density. See, positive is there. The surface of this cavity, it's a conductor. So due to induction, opposite charges will induce near the surface which is near to positive charge. Negative charges will be induced. This is a negative charge, opposite charges will be induced. So on this surface, positive charges will be induced. These charges, see, here positive charges are there, here negative charges are there. So the equal uniform distribution of charges are not there, non-uniform distribution of charges are there, and surface charge density is not equal to 0. Why? Because on the surface of this cavity, charges are there. That's why induced charges are there. So surface charge density is not equal to 0. So we must be very careful on calculating the surface charge densities and net charges on a body. So here this small discussion about charges ends. So we will go to next concept, Coulomb's law. You view that video also.